A key idea for understanding the performance of an electric vehicle is the relationship between the battery current and the motor current. We can explore this relationship using a simplified model of an EV powertrain. In this model, we have a battery, a controller, and a motor. To understand the relationship between the battery current and the motor current, we also need to understand the controller. In our very simplified but still useful model, we can think of the controller as an ideal power converter where the input power equals the output power. The battery supplies power to the controller at a voltage VB and a current IB. The controller supplies an equal amount of electrical power to the motor at a voltage VM and a current IM. Often, the controller is in torque mode, and the controller tries to maintain a requested motor current since that is proportional to the torque. For a given motor current, the voltage on the output of the controller varies with the speed of the motor. The power output of the controller is given by multiplying the motor voltage and the motor current. The controller then draws in the amount of battery current so that the electrical input power from the battery matches the electrical output power delivered to the motor. We can write an equation saying that the input power equals the output power. We can also write these powers in terms of the voltages and currents. So the battery current times the battery voltage equals the motor current times the motor voltage. At low RPM, the motor voltage is less than the battery voltage. This means that at low RPM, the motor current can be much greater than the battery current. At higher RPM, the battery and motor voltages are closer together, and so are the currents. To recap, the motor current is proportional to the motor torque. The battery current tells you how much electrical power is going to the controller, and the motor current is usually larger than the battery current at low motor speeds. In a future video, I'll show how the controller's battery and motor current limits affect your EV's performance. I hope this was useful and that you have fun riding your EVs.